In this video, we're going to look at a repository pattern with Entity Framework Core inside of ASP.NET. Hi, I'm Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. This video will be part of a larger playlist, which I'll link right up here if you want to check that out, and we're going to be talking about repository patterns, databases, and caches all together inside of practical examples. Now, some of these, like this video, will be more introductory, more foundational, and the intention is just to get the ball rolling to expose you to some of these concepts. That means that we won't be doing a super deep dive into Entity Framework Core or coming up with the most optimized way to do these things, but what we're going to do is create some of the building blocks so you can progress through leveraging these concepts. That means if you are an expert with Entity Framework Core, caching, and that sort of thing, you may want to move into other videos inside of this playlist, but otherwise, if you're just getting started, want to understand what a repository pattern looks like, how to leverage Entity Framework Core, and then later be able to leverage caches, this might be a great place to start. Now, let's jump over to Visual Studio and start walking through some of the code. What I have in front of us now is a sample web application inside of ASP.NET, and I have 4 GET methods. This is not traditionally what you would be doing, because if we're going to talk about something like a CRUD application with create, read, update, and delete, you would be using different HTTP methods, but because I'm going to show you this example just by going into the browser, I did make them all GETs just to keep things simple. So I'm just calling it out. This is not what I would recommend, but this is just to make it easy for us to see in the browser. So if I start expanding these, you'll see that I have a get method, which is going to be taking in a repository, which we'll see how to go build this. We're going to pass in an ID, and then we're going to ask our repository to get that. So this is the reading part of our CRUD API that will leverage a repository. If I expand these other HTTP methods, we can see that we have the create part. So I'll talk about how we go create an entity, go call the create method on our repository. We'll have a delete, and we'll also have update. So at a high level, I just wanted to show you that we have this simple web API. Again, all GET methods, not what I would recommend, but we're able to go exercise our repository that we'll be building. So because we have these 4 different methods at the high level of our web API, that means we're going to need a corresponding set of methods on our repository that we can go access. You might be asking yourself, okay, well, what exactly is a repository then? And this is a design pattern that generally is used to be able to control data access. That means when we look at the code that's on our screen right now, I have been telling you that we'll be doing things like getting data, creating data, updating it, deleting it. So we're manipulating data in some way, but I haven't told you exactly how that data is stored. So it's like an abstraction that sits on top of your data storage. Now, for this video, what we're going to be using is SQLite, just to keep things very simple. I don't have to run a database server anywhere. It's simply just a file. I'm calling that out because as we go through setting up your repository, if you decide that you would like to use a different database, you can absolutely switch to that. Because we're using Entity Framework Core, you will be able to swap to different implementations. There are other packages that let you leverage those other implementations. I'm just going with SQLite for simplicity. One more little bit of housekeeping that I want to talk about is that the entity we're going to be working with, if I jump over to that code, is extremely simple. There's not a lot going on here. It's just going to have an ID and a string value. So if you're thinking about a real application that you're building, you're probably going to want to have entities that have other types of data on here. I'm just doing this so that we can see that we're updating a value, and then we have a way to refer to our entities more specifically. This is inheriting from a base class, so if I jump into that, we'll see that this is a base entity. Every entity will need an ID. This isn't going to be extremely important for this video, but if you're going to watch the other videos that follow up on this, you'll understand a little bit more clearly why I've included a base class here. I'm not a big fan of including base classes, but this is a way to simplify how we can build out other parts that will come later. Okay, so we have a CRUD Web API. We know that we're going to be using a repository, but we haven't really seen how that works yet. And the entity type that we're dealing with, which is really just the data that we're working with, is pretty simple. So what do we start to do when we're working with Entity Framework Core? Well, one of the first building blocks that we need when working with Entity Framework is we need a DB context. So we're going to go look at how we create our own DB context. You'll see that I start off with this class on line 6. I just called it app DB context, and then it must inherit from this DB context. Inside of this constructor, I'm calling database ensure created. This is something that you may want to do in different ways. Like I said, this is just a beginner introduction to this concept. I'm not going to dive into all of the nuances. I just want to expose these different things to you so you can go explore them. This part here on line 14 is going to be a very important part of working with Entity Framework Core. The naming might be a little confusing because I called it entity, and you might be saying, well, what is an entity? This might be better explained if we had a more specific repository, say like a blog post repository, or if we had a repository of social media posts or some other type of data. Maybe you wanted to have a repository with models of cars. You could have a car model on your repository. This is just the set of data that is typed entity, and we've called it entities. So when we go to work with our data, I want to be accessing the collection of entities. This is what we're exposing out to people working with our DB context. Now, Entity Framework does allow us to override on model creating, because if we're trying to ensure that it's created, we need to make sure that we actually create it. So we have this model builder apply configuration, and if I scroll down a little bit more, because we only have one entity type inside of our database, and it's just the entity we've already seen, we can create a simple configuration just like this one. Now, what we're doing is we're ensuring that it has this key that's called the ID property, and then we have this property on the entity called ID, and this value generated on add. If we look at the tooltip for this, it says configures a property to have a value generated only when saving a new entity, unless a non-null, non-temporary value has been set, in which case the set value will be saved instead. So the value may be generated by a client-side value generator, which is what we'll be doing. We'll be providing the value, or may be generated by the database as part of saving the entity. So some database engines will allow you to have a schema that creates a value when you're creating a new record. So we are going to be controlling that outside of the database, but I just wanted to explain that you have this option here. Now, value is another property that we have on our entity, and we're saying that it is going to be required. But doing all of this means that we should be set up when we try to leverage this DB context that we're able to have a database schema created for us to use. This is one of the building blocks that we must have when using Entity Framework Core. You can see on my screen right now, there is no SQL code written anywhere. I mentioned that we're going to be using SQLite for this example, but as you can see, this is going to help us ensure that we have that schema without writing any SQLite, which is great. So going back to the program.cs, what I wanted to call out is now we have this idea of a repository. We have a high-level overview of our CRUD API. We've seen the basics of an entity, and now we know one of the building blocks for Entity Framework Core. So how does that DB context and the repository pattern come together? Many people will debate this online, and I'm not here to tell you which side to pick. Some people will say, hey, if you're dealing with Entity Framework Core, you absolutely don't need a repository pattern. It's overkill. It's just too many layers of abstraction. Other people will say, hey, you want to hide that detail that you're working with Entity Framework Core. You absolutely want to wrap it in a repository so that that's a detail we don't have to see. I am not going to tell you what's right or what's wrong because I think that will depend on the context. This video is talking about wrapping the database context in a repository pattern. If you're against that idea, you don't think it's going to be suited for your needs, then you don't need to do that. You don't need to feel like I'm forcing you to do that. I'm just showing you how we can. With that said, we have to find a way to take this repository interface, and I've only briefly showed you how we can call it. We haven't even looked at the interface. We need to see that, and we need to understand how that's going to work with our DB context. Let's go look at the class and the interface for this repository. If I jump over to this file here, you can see at the top I have an iEntity repository, and this is going to have all the methods that we want from our CRUD API that we can call. So we have this create method. You can see that at a quick glance here, these are all async calls. I'm using value task. This is a detail that will come up a little bit later. You might be saying, why value task and not task? Maybe if you're newer to async await style code in C#, you might be saying, I didn't even know there was a value task. It's not something that's super common that I think people are thinking about, but we will touch on this later when we talk about caching. So don't worry too much about it for now. If you're finding it confusing, just pretend that this is a task for now, and then we can get into those details in future videos. When we're calling create on the repository, we're going to pass in the entity that we want to go into the database. When we're calling delete, all that we need to specify is the ID of the entity that we want to delete, and the return value is going to be whether or not that thing got deleted. So for example, if we only had one record that had the ID 123, and we said go delete ID 456, this won't throw an exception, it will just return false. So just an explanation of how that works. I did include a getAll method here because this is something that might be pretty common to have on something like a repository. We're not going to be leveraging it in our CRUD API, but if we wanted to be able to get everything, we could do that. Get async down here is just going to take in an ID that we want to look for, and it will return that entity if it's found. And you'll notice that this is marked as nullable because if we don't find one, instead of throwing an exception, we'll just return null. And finally, the last method that we have is update. So we will pass in an entity, and if it does get updated, then we will return true, otherwise false. This is a bit of an interesting one. We'll see when we look at the implementation of this, because I think that there's different ways that you could think about this API. Just a reminder that as I walked through these methods, you might have a different idea of what you would want on these different API calls in terms of the parameters that are being passed. Maybe if you wanted a get method, you want to pass in an expression to go look things up. This is just a high-level overview, and I want to encourage you that you should be going to explore these concepts further. This is just an intro video to walk through some of the basics. Now let's go see this class. How do we go take this interface, which is what our callers will see, right? Our CRUD API will be calling this thing. So that means it sees these methods, but if we want to go wire that up to that database context, how does that all look? So that's going to be in this class right here called EF Core Repository. You'll notice that it's inheriting from iEntity repository. What we're going to do is pass in an IDB context factory. Again, if you're very new to Entity Framework Core, I haven't touched on this part yet, but you'll see that on line 31, the type of the DB context factory is that app database context that we talked about. This is the one we've already seen. So the idea is that we want to ask the context factory to create a context for us when we're going to work with the database. That means that at this point, if we're looking from lines 31 to 36, talking about the constructor being called, what we're not doing at this point is opening up a direct connection to the database. That's not what's happening. We're providing in objects that allow us to go connect to the database when we need to. I just wanted to make that very explicit. This is not opening a connection to the database. When we start calling the methods down lower, so say for example, down here, when we're exercising this code, this is where we will be able to go have a connection to the database. If you're dealing with more complicated multi-threaded applications, especially if you're running something like a web server, if you are just using one database context and passing that around everywhere, you may encounter some challenges, which is exactly why we want to make sure that we have a factory to be able to create it so we can use it only in the scope that we're working with it. Again, if that sounds confusing and you want more details on that, I do suggest you watch additional videos because this is just an intro so we can see some of the patterns. Okay, so if we start stepping through some of the implementation here, the common thing you'll see is that all of these will be creating a DB context, right? So we have the factory, we're going to ask to create an instance of that context. It is disposable, so we want to make sure that we have a using out the front. If you're not familiar with what using is, this just means that this is something that is marked as disposable. When we leave the scope of this method, it will dispose of it. You might have seen this pattern before. This type of using statement is a little bit newer, depending on when you're watching this. Other times you might see that it's using, and then you have to have the entire block of code scoped inside of a using block. This is just going to be the same thing, except when we exit this method, it will essentially call dispose before leaving. Just a heads up if you're not familiar with that. On this next line, 44 through 48, we can see that we're using that context and we're asking for that set of entities. So this is kind of like the collection that we're trying to access. And then we're going to ask for the first or default, which means we're going to look for something that matches this pattern here, which if you have a close look is just saying, give me the one that has the same ID. And if we can't find it, what it will do is return the default of entity. Our case, that will be null. So this code here is essentially going to ask our SQL database behind the scenes, thanks to Entity Framework Core, hey, go find me the entry with this ID. If you cannot find one, give me null. One of the main reasons that people love using Entity Framework Core is that this block of code right here, and what we've seen so far, you have not seen anything to do with the database. People love this. If you don't love writing SQL and you want to keep that completely abstracted, you're essentially able to work with the database without writing any SQL code. That can be awesome. For me personally, I actually like having SQL. I use different things called Dapper. We will see that in future videos. But what I wanted to mention just a little bit more specifically here is that when you're exercising this, this will go run SQL code against your database. It's just that transformation happens behind the scenes for you. Let's move on to get all async. This one's going to be very similar. Like I said, it's not actually leveraged from our CRUD API. I just wanted to show you. So similar thing, get the DB context. And then here, we don't have a filter, right? We're not using first or default because we're not looking for a specific ID. We're just saying, take that whole set of entities and let's go map it to an array. That way we get the whole thing back. This may not be something you want to do on a database with a ton of records. If you're dealing with a table that only has a few things in it and you know that for sure, this could be a method that you want. I've certainly built applications where I have a table of configuration values or something like that, and I know for sure that I can safely pull those all into memory, not be concerned. And I've written some other applications where that would be absolutely detrimental if we said, hey, there's 1 million records in the database, let's go pull all those into memory. Not going to fly so well. This is just an example, but I wanted to warn you that if you're not thinking about the data that's in the database, this might not be something that you want on your repository. So consider that. Next, let's go to create. This is going to, again, start off with that DB context being created. And you can see that on the set of entities, we're calling add async and passing in the entity. When we were looking at setting up the app DB context, if you recall, when we were ensuring the database was created, we said that our entity has an ID and a value. And we said that ID could either be created from the database or from the client side. When I'm designing repositories, personally, I like ID creation to happen outside of what I would call my data layer. So I personally like my application layer that sits above the data layer to be responsible for creating those IDs. But there may be other use cases, perhaps where someone says, hey, always let the database create the ID, or always let my data layer, so still in code, not in the database, I want that to create the ID. So in here, like in this method, you would be setting up the ID. But the way that we're going to see it is that when we call create async, we will be creating an entity with a new ID. I just wanted to mention that because, like I said, this is an introduction, and if you want to understand those concepts better, now you might have a bit of framing for other things to go search. So in the database to create your ID, in your data layer, like right here, or the calling part that's above this, so maybe in more application logic. There's 3 different scenarios that I just gave you. You could probably think of more perhaps, and maybe the reasons that you want to do that will change. So something to consider. Now, let's go look at update. An update is probably the most complicated one we have, and I did mention that depending on how you want to go implement update, you may have a different perspective on what should happen here. So I wanted to walk through this because it deserves a little bit more attention. We start off the same way. We've already seen this a handful of times. What I'm going to do is, in my implementation of update, I only want to update an entity if it exists. So how I wrote this in here says, let's go check if it exists. So what I'm doing is asking for the first or default. So this is very much like the get we had. If we scroll back up, right, you can see that we're doing first or default based on the ID. Let me scroll back down. Same idea here. However, what's happening is I have this as no tracking. This is a huge tool tip to go read through, but I'm going to explain why I'm doing this. If we check if the thing exists and we say, hey, wait, it doesn't, I don't want to perform any further action. Some people may want to have something that's like an upsert or a update or add. You may want to do something different. In my case, I'm saying if it doesn't exist, we're not doing anything at all, and we're going to return false. If we go down a little bit lower, you can see that what I'm doing is I'm taking the entity that was passed in and I'm setting the state of that entity to be modified. Then I'm calling on the DB context to save those changes back into the database. What's interesting here is that if I do not have as-no tracking and I try to perform this action, what could happen is that it will say, hey, look, there's already an entity that has the same ID and you're trying to basically save the changes back. But I have these two things being tracked. What am I supposed to do? So this is a little bit more detail into Entity Framework Core. If you want to understand these things more in depth, please continue watching other Entity Framework Core videos. This is just an intro to repositories. A different way that we could probably do this is instead of me trying to save this one, right? So if I'm marking this one as being modified, what we could be doing is trying to copy over the values from the other entity, and then we could go save that. But I'm not doing that here. I'm not even using that entity that comes back. I'm simply checking if it exists. So there's different ways you could do this. We could also, like I said, maybe we wanted to add the entity if it doesn't exist. I'm just trying to show you that if you want different behavior in your repository, these are different things to think about. Again, if you want to go implement different things, you have a different approach to this. No problem. I'm not telling you this is the only right way or anything like that. Just some options. Let's go look at delete. And delete is kind of similar in that we are checking if something exists first. That way we can go remove it from the set and then we can save the changes. So very similar. We're going to try finding the thing by its ID, right? So we look for it. If it is null, we don't have it, then we're just going to return false. We didn't delete anything. We're not going to throw an exception, just say, hey, nothing to delete. If we did find it though, we're taking that reference and we are removing it. Then we can save those changes back to the database. Overall, these are a few different methods that we have on our repository and how we can take that repository interface and call the needed methods in Entity Framework Core. If you can see, if I just collapse these, this idea is that we basically have one more level of abstraction over Entity Framework Core with our repository. And like I said before walking through this part of the code, some people will say that's absolutely overkill. I just don't want to have to deal with that. Let me literally just go wherever I need to go do this kind of thing. Just work with the database context itself. So I'm not here to tell you it's right or wrong. Just showing you this is how you could wrap a repository pattern around Entity Framework Core. Let's go back to program and see how we can wire these things up, and then we'll actually start calling this from the browser. To make this work, if you're not familiar with dependency injection in ASP .NET Core, I have other videos on that. There are plenty of other videos on YouTube you can go watch. But what we're going to be doing is leveraging dependency injection so we can use these services. And that way, if we go back to our minimal APIs, like right here, for example, when we say, give me the entity repository, this will ask our service collection, hey, do you have an implementation that meets iEntity repository? And thanks to dependency injection, which we'll walk through in just a moment, we'll be able to find the instance that we need. Let's go into setup EF CRUD. This is an extension method that I've created. And what we're going to be doing is on our web application builder, we will ask to add the DB context factory specifically for our app DB context. This is the one that we created. We've already walked through it. When we were looking at our repository, this is the type of the DB context we were using that has that set of entities directly on it. So we've already seen this. This is how we add into dependency injection, having that DB context factory. And for the first time, you're seeing some SQLite specific stuff. We're saying, hey, when we're using this DB context, it's going to be SQLite. And this data source, this is the connection string that's right in here. This connection string just says the data source is going to be test.db. You could use an in-memory database if you're using SQLite. You can use a file. If you're using other databases instead of use SQLite, you would have something like use, and then you could say like MySQL, or you could have SQL Server or Postgres, lots of other options. We're using SQLite here. So that's setting up Entity Framework Core to connect to our database. Beyond that, the only other thing that we're adding in to the dependency injection framework is a singleton. So there will be one instance of this ever, which is going to be our repository. Something to think about here, just to make sure we're all on the same page, is I'm saying one instance of the repository. That doesn't mean one instance of the DB context. Recall, up here, we're adding a DB context factory. Every method that we saw inside of our repository is going to ask that factory to make a new instance of the DB context for us. It will say, hey, factory, give me that instance of the context. So it's not one context, it's one factory and one repository. Just to be clear, because this might be confusing for some people when they see singleton. The reason is this repository does not need any state, and we don't need to make sure that we're managing that state and having separate instances. So just a heads up, that's why this is a singleton. With all of that put together, that means once we have this builder line run and we set these up, we've now configured Entity Framework Core, and we've hooked up an instance or the type that we need to have that meets our iEntity repository. We're off to a great start here. So at this point, we should be able to go run our web application, call the CRUD methods that we have, and see that it's actually taking an effect. And I think what would be helpful is if we start with the create, because we haven't talked about creating that ID. I'm just using a random number here, but let's go check this out. We're going to call create and get this thing running. Okay, and just to show you that it's up and running, it says it's listening on localhost 7230. We don't really need to watch necessarily in here, so I'm going to minimize this for now. We are going to go over to the browser, though, and try to position these in a way that you can see them, and that I can see them too, because the camera is in front of everything. But we're going to do a create call. Now, recall that I did say that these methods here are all HTTP GET methods. Probably not what you would want to do when you're building out an API, but this is just so that I can call it in the browser and you can see it. So we call create, we're going to hit our breakpoint. What we're going to do is create a new entity. So if I hover over this, yes, I'll have the editor zoom in so you can see what's going on, but we have this entity. It has a randomly generated ID. This may not be what you want to do. Like I was saying earlier, if you want your database to go create IDs for you, like that increment automatically, you can absolutely do that. You can use GUIDs for your IDs. There's different strategies around that. People will tell you different things there. And something important to consider when you're building out a real database. And in my case here, I'm just generating random IDs. I would say this is not super great practice because you can absolutely have collisions like this. But just to make this demonstration easy, I just wanted to have this up and running and show you that we can create IDs at the application layer. So something that's not right at the repository, something that's outside of that. And then the value. This part was just for me to go generate any random value, not super important here. I just didn't want it to be an empty string. Now, inside of our minimal API, I'm going to go into the repository part now. So we've created an entity in memory. If I step into this, well, it didn't step into it. It just executed very quickly. So I'm going to repeat it again, but let me go pull it up so we can see. It did actually go create something. So let me call it one more time, and I'm going to put a different breakpoint a little bit lower for us. So let me go into here and I will instead run to this part. So just because I don't trust my debugger right now, if I press F10, see we got the DB context made, right? We have an instance of that DB context. Great. I'm going to call this line now where it will add, but we haven't saved the changes, right? So this added it to the collection, but this is going to actually cause Entity Framework Core to go write that data back to the database. So if I go do this, now we have added that record. You can see, if you pay attention down here, that the SQL part was actually being exercised. Just to prove it, if I pull this up too, I was saying we didn't need to go watch up top here, but you can see that it has a DB type integer for the first parameter, and then it has a question mark for the second parameter because I have a string there. And then the actual SQL that was run against the database is insert into entities, And then it has ID and value because those are the two properties on our entity type, and then the values that are these two parameters. This is the part that you don't have to think about when you're using Entity Framework Core. We didn't have to write any SQL. So this is one of the main reasons that people love using Entity Framework Core is we don't have to think about this for really simple things. When it gets more complicated and you're debugging stuff that is a lot more complicated than just a simple entity table like this, yes, it's probably going to be very helpful to understand the details of SQL, but for this case, probably not that important. So let's go back. We can step through this. And when we go to return this, we can see that we're just going to pass back the entity to the caller. That is how we create one. Great, we have this. I'm going to zoom out a little bit. We have this ID now, though. Okay, so what is another method that we could go do? Well, let's see if we can go get this entity back. What I'm going to do is we're going to look at FACF right at the end of this GUID. That's one of the drawbacks to using GUIDs and making videos like this is like, hey, go memorize this, everyone. And I don't want to copy it somewhere else, so we're just going to remember FACF at the end. Now, our GET API, if we look right up here on line 11, is just going to be, right, the root, and then I'm going to pass in this ID. Now, when I press enter, I'm not putting a breakpoint on here on the GET method, but we should see, if we think about what's going to happen, line 16 will go to the repository, which calls Entity Framework Core, looks for a record with this ID, and then it will return it to us. We should see this exact same text come back. So let's go try it. And there we go. The exact same text came back because that is the entity that was matched. If instead I change this ID to be something completely different, so I put 222 here instead, and I run this, you can see that we just get nothing back. So that's because when it returned OK, the entity that came back was null. So not a great API design, but that's why we don't see anything here. So that's the reason for it. If I put 175 back, you can see that we are getting that entity. So far, so good. We've done create and we've done a get. Let's go update this thing, though. So let's scroll that into view, update down here, and maybe we should step through this one because this might be more interesting. But if we have this part and we want to look at update, that means we need to have a /update here and then the ID, but then we need to give it a different value. So let's call it dev leader for the value, which is here. Okay, so these are the two parameters, right? ID is on line 41, value is on line 42. If I press enter here, we should be able to go in. Because my debugger is being a little bit funny, I'm going to put a breakpoint here, and here, and here. So F5 into here. Let's see, does this thing exist? If I press F5 again, and we hover over exists, it says, yes, it does in fact exist. I'm going to jump down to here. We can see that we're going to take this entity, which is the one that we created at the minimal API level. It says that the ID is the one we passed in. Dev leader is the value right from the URL bar. We're going to set that state to modified and save. It did it all at once because my debugger is being very funny. And then it returned true because our minimal API is saying if it does update, it will return true. Let's go back and get it calling this. And you can see that when I call get now, this is the value that was in the database now, because that's what we just updated it to. If we want to go back to this, and let's go change this to be 222 instead, right? So we're saying we want to go update this record ID. We know that doesn't exist. I just made this up, and we want to set that to be dev leader. When we go into here, again, I'm going to jump over, press F5. We should see that when I press F5 one more time that exists is false. And if we have a look, exists is false because the ID was not found. Now when I leave here, it will return false all the way back to the browser. So far, so good. One more minimal API to check out, and that's going to be delete. This one is pretty simple. Let's start by deleting the one that does not exist. Okay, so if I call this, let me go back to here so you can see. we're going to get a Boolean value back. So if I try to delete one that doesn't exist, what should we see come back in the browser? It's either true or false. So let's go see. We get a false that comes back. That ID simply doesn't exist. Now, if I put 175 out here, it did apparently delete it. But how do we go confirm that it's actually gone? Well, we can go call the get API once more. And that get API is right here. So now we should see a white screen come back because this thing should be out of the database. And there we go. We've successfully created, fetched, updated, deleted, and then refetched one entity using a repository pattern over Entity Framework Core. So this was just a high-level overview of how you can wrap a repository pattern over Entity Framework Core, but in the next video, what I wanted to show you is that we can do something a little bit different here. This is because if we look at our entity repository that we created and the methods that we have, there's something that we can do a little bit differently here. Everything that we set up here is actually something that could probably be very generic. There's nothing really unique about these entities. What I mean by that is the only real thing that we need to deal with on the entity is this ID. Everything else in terms of these APIs that we have, if we look up here, right, it's just going to be an ID or entity coming back. And even in the implementation, there wasn't anything really fancy going on. It wasn't like there was a special property we had to go set up or join across other things. This was just, is there an ID that matches? If there is, give it back. Or if we were updating things, it was just, hey, you already have this entity, go mark it as modified and then save the changes. So in the next video, what we're going to look at is transforming this into being a generic repository that we can wrap around Entity Framework Core. Thanks so much for watching this. And if this was too simple or you want to jump around, remember to check out this playlist above, and that way you can go pick something that's more appropriate. Thanks, and I'll see you in the next video.